Hello, welcome back to Cretitas Math. So today we're looking at how to graph linear equations. So in graphing linear equations, there's two main methods that I would want to talk about today. So the first method is what I call walking from the initial value and using the slope. So here I've already prepped us so that we could jump right in. We have this Cartesian plane, our x-axis, the horizontal axis, and the y-axis, which is the vertical axis. And I've scaled the graph where each square is 1. And now looking at our equation here, we have y equals 3x minus 4. So using method 1, the first thing that we need to do is identify, well, which of these numbers here is our slope and our initial value. So we have this 3 and we have this negative 4. So the 3, this here is the slope. And if you remember, slope is your change in y over your change in x, which is your vertical change over your horizontal change. And since our slope is 3, then we can think of that as 3 over 1, which means we have a vertical change of 3 with a horizontal change of 1. And since this 3 is our slope, that means that negative 4, that is our initial value. So this right here, that is initial value. So this method is nice and simple. So when I say walking from the initial value, you'll see what I mean in just a second, but we're basically starting from the initial value. Oh, look, I forgot that word. So this negative 4, we need to start off by plotting that on the graph. So here when we say we start at negative 4, it means that when x is 0, which is right over here in the origin, that means y is negative 4. We're starting at x equals 0, we're starting at a value of negative 4. So that is our first point. And now we're going to walk from this point to our next point using our slope as our guide. So our slope tells us that we have a vertical change of 3 and a horizontal change of 1. So I'm going to zoom right in here. And we are going to walk vertically from this point. We're going to go up by 3 and we're going to go across by 1. And now I have found our new point. And if I wanted to put in a third point, I would do the same thing. I'd go up again by 3 and across again by 1, and I'd find a third point. And now 3 points is plenty of points for you to graph a line. So if you're doing this on paper, you put a ruler, you line up these 3 points, you draw a line right through all 3 of them, and then you would extend your line in both directions to the edge of your graph, since the lines are infinite. They go on forever. And that's how you would draw this line using that first method. So walking using the slope from the initial value. And I think that that is probably the easiest method, but it does only apply to linear functions. The next method is creating a table of values, and this is a method that applies to any function. So for creating a table of values, you're going to start off with a table of values. And I like using the vertical version of a table of values. I'm sure you know that you can also use a horizontal version of it. But the benefit to using a vertical version is that once your numbers are in here, they kind of already look like coordinates, which makes it a little bit easier to read because your x is already on the left, your y is already on the right, and you kind of know, okay, well, x goes first, y goes second, and it becomes a little bit easier to plot those points on the graph. So now since we're using the second method, I'm just going to erase all of this stuff. Okay. So now when you're using a table of values, you're working off of this equation here. So you're working kind of with the algebra. I want to rewrite it over here. And what you want to do is pick one number. So we're going to pick an x value. And basically what we're doing is we saw that line that was just there. That line has a point for every value of x. If you kind of go along your x-axis, there's a point that exists on that line at all of those x values. So you want to find the y value that goes with whichever particular x value you're interested in. So it doesn't actually matter which x you pick, you just have to choose one. So looking here, a number that's really easy to work with is 1. So we're going to see what happens at 1. So we are choosing that x is 1. You choose that. And now what you have to do, this is the part where the actual equation comes into it, is now that you've picked x is 1, well, you have to figure out what y is for this particular line when x is 1. And so the way that you do that is you replace this x with the value of 1, and then you use your order of operations and you solve it. So 3 times 1 is 3, 3 minus 4, that's negative 1. So in here, you put in that negative 1. So you have found the value of y when x is 1, and you chose that x equals 1. And then you put that point right in here. So x is 1, y is minus 1. And that's why I like this vertical version, because it's kind of already like a little coordinate. And now we need another point. So any other point on this line, let's go with x equals 5. We'll see what happens there. So again, I'm choosing that x equals 5, and now I'm going to see what happens when it does equal 5. So over here, I'm going to replace the x with a value of 5. And everything else is as normal. So now 3 times 5, 15. 15 minus 4, that is 11. So over here we have a value of 11 for y. So we're going to take a look at 5. Whoop. Oh no, 11's not on the graph. So since 11's not on the graph, we're actually not going to use 5. This is, I don't want to say a useless point, because it still exists on the line. It's not wrong. It's just not useful right now based on the grid that we have. So we actually have to go a little bit smaller. So let's go down to 3. 3 should work. And you don't even have to erase it. You can just leave it there. It's just, it wasn't useful in the end, and that's fine. So now we're going to look at what happens when x is 3. We do 3 times 3, that's 9. 9 minus 4, that's 5. So we get y is 5 when x is 3. And this point is on our graph. Now these 2 points, you just connect the dots and extend your line in both directions. So if ever you encounter the situation where you get something like this, where the y value you calculated in your table of values is kind of off the grid, I would suggest that you don't start extending your grid and, scribbling kind of other numbers and trying to fit it on there. I would encourage you to just pick another number that's maybe a little bit smaller, another number that you think might work better. And you can leave all that work in there so that your teacher knows what you did, but just pick another number that works a little bit better. And that'll be easier than starting to kind of fiddle with the question. Another thing I want to mention is that in this case, well, in this example, we were choosing x values and then finding the y values that went with them. But you could also choose y values and find the x values that go with the y. The reason why I didn't show that is because since our equation is written out in this way of y equals 3x minus 4, you'd have to do a whole bunch of extra algebra work to move things over and divide in order to solve for x when you're choosing a y value. And that's a lot more work than you need to do, which is why I didn't do it, but I just wanted to mention that it is possible. It's just not very convenient in this case. Okay, so those are the two methods. I'm going to do one more example, and I'm only going to do it using the first method since it's faster, and I'm also going to kind of run through the example a little bit quicker. Okay, so the first thing to do is starting with this initial value. So putting that right on the graph right away, and now using that slope to walk from the initial value. So our slope minus 2, that's our vertical change, and positive 3, that is our horizontal change. So from this 6, I'm going down by 2, across by 3. So down by 2, across by 3. Get a point here. Down by 2, and across by 3. And we get a point here. Now we have 3 points, and that's plenty of points to draw a line. So we just join all those points, extend that line until the edge of your graph in both directions. And that's that one. And then very quickly we will look at this one here. This is a direct variation. So you have to remember that the initial value is 0, which means that you're starting from the origin here, right in the middle where the two axes cross. And here we have a slope of -6, which means -6 over 1. We're going down by 6, since this is our vertical change. And we are going across by 1, since this is our horizontal change. And if you noticed here, this graph is scaled by 3. So every square counts for 3. So I'm going to use the same walk across method. From this initial value point that we have, we're at 0, 0, since that's where we start. We're going down by 6 and across by 1. So down by 6 and across by 1. It's going to go right in here. Then we're going down by 6 again and across by 1 again. So that's those 2 extra points. And at this point you can join those 3 dots and then extend your line. And that is it. Okay, so I hope that this was helpful, and I will see you in the next one.